This module will show you how to complete the non-parametric alternative test for the independent t-test, known as the Mann Whitney. When data is not normally distributed, then non-parametric alternative tests can be used. These tests use inferential methods that do not assume a normal or any particular form of population distribution. They are sometimes known as assumption-free tests. Typically, non-parametric tests are used when parametric assumptions are violated and corrections to the data cannot be made. Non-parametric tests overcome non-normal distributions of data by ranking the data. Ranking overcomes the effect of outliers and any problems with skew. Hence, non-parametric tests are based on the median. Therefore, it is critical if you are reporting non-parametric results that you also report medians as a minimum in your descriptive statistics. The Mann Whitney test, also known as the Wilcoxon rank sum test, is a non-parametric alternative to the independent t-test. It compares two independent conditions. Statistically, the scores for each independent condition are ranked from lowest to highest in count intervals. The mean rank value tells you how the groups differ, while the test statistic indicates whether this mean rank is statistically significant. When you open the data set, you should have a data file with 4 variables. In the Data View tab, we have our ID variable from 1 through to 20. We have a categorical variable for drug, with 1 being ecstasy and 2 being alcohol. And then we have 2 continuous variables, Sunday and Wednesday, with Sunday being the Beck Depression Inventory Score and Wednesday being the Beck Depression Inventory Score. In this worked example, we want to know, is there a difference between the Beck Depression Inventory Score on Sunday for the 2 different types of drugs? To answer this research question, we need an independent t-test. First, we need to explore the 2 continuous variables and check these for normality. If they are not normally distributed, then we can proceed with this non-parametric alternative test. Come up to Analyze, Descriptive Statistics, and Explore. We put both Sunday BDI and Wednesday BDI into the dependent list. Under plots, we want no box plots, normality plots with tests, and we want to deselect stem and leaf and select histogram, and then click Continue. Select OK. The initial bit of wording will show you the output that you've asked SPSS to do, and then you'll have your case processing summary appear. We can see that there's 20 people with a Sunday and a Wednesday score with 0 cases missing. When we have a look at the descriptives table, under the descriptives table, we can see the Beck Depression Inventory Score for Sunday has a mean of 18. When we have a look at the minimum and the maximum, we can see that's 13 to 35. So we know that that fits within the expected range for the scores. However, when we have a look at the skewness and kurtosis scores, these are quite large. They're a fair way away from the ideal of 1. So we will be expecting that these Sunday scores are not normally distributed. When we scroll down to have a look at Wednesday, we can see the mean is 21, minimum maximum scores 3 to 39, and the skewness and kurtosis scores for Wednesday are actually not quite as bad as we'd expect. They are still a little bit, especially for kurtosis, away from 1, but they're not extremely far. So when we have a look at the tests of normality table, we can see by looking at the Shapiro-Wilks statistics that the p-value for Sunday is 0.000, and for Wednesday it's 0.010. Because these values are less than 0.05, we know that they are not normally distributed, and therefore we can continue with a non-parametric alternative test. We can double check the histograms and we can see that they are quite far skewed. The points are sitting fairly off the QQ plot, although the second histogram doesn't look quite as bad, and we could see that from the skewness and kurtosis scores. However, when looking at the QQ plot, there's a lot of points fairly off that linear line. So now that we've confirmed that our two continuous variables are not normally distributed, we can proceed with doing a non-parametric test. To run the Mann Whitney, we come up to Analyze, come down to Non-Parametric Tests and select Independent Samples. Under this window, we do have three options. It lets you automatically compare distributions across the groups, compare medians, or customize your analysis. One option is to leave the default of automatically compare distributions across groups. If you select fields in this mode, you will see it automatically detects the test fields for you. And if you select settings, our area down the bottom is actually grayed out. However, to learn today, let's customize our analysis. So come back across to your Objective tab and select Customize Analysis. When you come across to your Fields tab, we will need to move out the numbers. So for Sunday and for Wednesday, given in this example, we only want to know if the Sunday Beck Depression Inventory score is different between the alcohol and the ecstasy groups. We'll move Wednesday back out. And we'll move type of drug into our groups. Come across and select your Settings tab, and we select Customize Tests. We want to select Mann Whitney, which is talking about having two samples. So that is our alcohol sample and our ecstasy sample. Once you've ticked that, we can come down and select Run. The first table gives you a hypothesis test summary. It will tell you whether you need to reject or retain the null hypotheses. And this is based on your p-value. As your p-value is 0.280, that tells us there is no significant difference between the Beck Depression Inventory on Sunday ranked scores between alcohol and ecstasy. Because this is not significant, we retain the null hypotheses. We can then come down to the test summary table for more information. The first row, total N, indicates your sample size of 20. Your Mann Whitney U of 35.5 is your test statistic. And if you come down to the bottom, your exact sig is your p-value of 0.280. And as this is greater than 0.05, this means that there is no statistically significant difference between the two drug groups. There's also a figure which will allow you to visually see the display of the scores between the two groups. The next thing you'll need to report your findings will be the median. So this isn't provided in the output, so we'll need to get this separately. We come up to Analyze, Compare Means, and come across to Means. In our dependent list, you put your outcome variable, which is our Sunday BDI score. And under independent, we put our categorical variable, which is type of drug. Under options, we can select what statistics we want the output to show us. So in this case, we can bring mean down, so number of cases, mean, standard deviation. And then we also want it to tell us the median. Click continue and click OK. Case processing summary tells us it's used the whole sample. And under report, we can see that the mean score is 19.6 for ecstasy and 16.4 for alcohol. And because this is a non-parametric test, we're actually interested in reporting the median score. So the median score is 17.5 for ecstasy and 16 for alcohol on the Beck Depression Inventory score. To report your findings, you'll need to draw information from this table, as well as from the test summary or the hypothesis test summary table. To report, you would say something along the lines of, there was not a significant difference in Beck's Depression Inventory Sunday scores between ecstasy and quote the median of 17.5 and alcohol, median of 16. You then report your Mann Whitney U test statistic of 35.5 and your p-value of 0.280. If you are using hypotheses in your write-up, you can report that you have insufficient evidence to reject the null hypotheses. Please note that depending on your application, you may also need to go into effect size, which looks at the magnitude of the difference. However, please seek further statistical advice if this is required.